ARMO Behavioral Cloud Application Detection and Response is the first cloud runtime security solution to provide a holistic view of a real-time threat from the line of application code being exploited to the cloud API where the data resides. It links high-level cloud activity to suspicious application-level behaviors, providing detailed visibility into the compromised application function and APIs. Today, we're simulating an attack on a web application deployed on Kubernetes with ARMO CADR installed. We'll start by attempting to log in with the username admin, but as expected, we encounter invalid credentials. Let's launch an SQL injection attack. If the application doesn't properly sanitize user input, an attacker can exploit it. We successfully gained admin access. Let's try to exfiltrate the service account token of the database pod using an error-based SQL injection. However, we need the full token. We'll switch to our terminal and automate the extraction with our script. As we extract the service account token, let's switch over to the ARMO platform. We can see two new incidents. We'll first investigate the possible SQL injection attack on the web server. Here, we have complete attack details. Looking at the raw request, we can see the exact SQL injection payload. Let's look at the second incident. In this case, the MySQL process is accessing the token, although it is not supposed to. Now, let's continue with the attack. We'll save the service account token as an environment variable and use it to authenticate to the cluster. Let's start by identifying the MySQL and PHP pods. Next, we'll enter the PHP applications pod. Inside, we will examine the environment and execute a few commands. Our objective is to run a script that authenticates to AWS, leveraging the node's permissions, and creates a new S3 bucket. Let's delve deeper. Let's create a username called Hacking is Fun and grant it access to the S3 service. We have successfully created the user. Notice how it lists the buckets and creates a new one for us. We've uploaded a test file and subsequently downloaded it. With these steps, we've verified our successful authentication with the AWS cloud. Finally, we've created a symlink to the shadow file. This strategy allows us to avoid direct access to the shadow file in order to evade detection by standard monitoring tools. Instead, we'll read the shadow copy. Now, let's return to the ARMO platform to see the detections. We detected a new incident showing the attack flow. A bash process triggers Python, which interacts with the cloud to create a user and a bucket. Scroll down a bit and we see a list of events, including the creation of a user. All key details, including the raw event, are clearly visible. We can also observe the S3 bucket access and the soft link created over Etsy Shadow. By clicking here, we can view the call stack originating from the creation of a symlink over this script. This gives us a comprehensive understanding of the entire attack flow. We also have the Explain Incident option. Here we can see a container compromise and AWS account exploitation. The sequence of suspicious activities and the entire attack flow are laid out clearly, starting with the execution of Create IAM User, moving to the creation of symlink over shadow file, and ending with communication to AWS to create an S3 bucket. Feel free to navigate to the action section and execute any desired action.